Right now, in this exact moment, the space between your eyes and the screen you're looking at is expanding. It is a physical fact, occurring at a level so fundamental that the atoms in your body are subtly being pushed away from one another. Yet, as you sit there, you feel absolutely nothing. Your coffee sits perfectly still in its cup. The walls of your room do not groan under the tension. The world around you feels solid, static, and dependable. This is the great deception of the human experience. While you occupy this stillness, the road beneath your house is lengthening. The distance between our planet and the nearest stars is stretching. We have spent centuries looking up at the night sky, assuming we were staring out across a vast empty room. We thought that if we just had a powerful enough telescope, we could eventually see the walls. For decades, our best guess, our most confident measurement, was that the observable universe stretched about 14 billion light-years in every direction. It was a number that felt big enough to be meaningful, yet small enough to be measurable. But we were catastrophically wrong. The James Webb Space Telescope has just confirmed that the universe is not 14 billion light-years across. It is 93 billion. That is not a minor adjustment. It is a total collapse of our previous reality. To understand why this number is so disturbing, you have to realize that this extra space didn't come from galaxies flying away from us through a pre-existing void. Instead, it is the result of space itself being created. Imagine you're standing on a long motorized walkway at an airport. You're walking forward at a steady pace, heading toward a destination you can see clearly in the distance. But as you step forward, the walkway beneath your feet begins to stretch. It is expanding faster than you can walk. Even though you are moving toward your goal, the destination is actually getting farther away. This is the cosmic treadmill. This is the true scale of the universe as revealed by the data. This is not speculation. This is a measured physical consequence of the expansion of the fabric of reality. When the James Webb Telescope captures the light from a distant galaxy, it isn't just taking a picture, it is performing an act of cosmic archaeology. It is catching photons, tiny packets of energy, that have been travelling through the void for 13.5 billion years. Think about that timeline. When those photons began their journey, the Earth did not exist. Our sun had not yet ignited. The Milky Way was nothing more than a chaotic swirl of gas and dark matter. Entire geological eras on our planet, the rise and fall of the dinosaurs, the shifting of continents, the entire history of human civilization, all of it occurred while these specific photons were still in flight. They were crossing a distance that was growing while they travelled. By the time that light finally hits the golden mirrors of the telescope, the galaxy that emitted it is no longer where we see. While the light was in transit, the universe carried that galaxy away, pushing it to a current distance of 46 billion light-years. This leads us to a disturbing realization that many transcripts ignore. We are not living in one unified universe. We are living in a multiplex of reality. Because space is expanding so rapidly, there are regions of the cosmos that are moving away from us faster than the speed of light. This doesn't violate physics, because the galaxies themselves aren't breaking the speed limit. The space between us is simply growing too fast for light to ever bridge the gap. This means that there are galaxies we can see right now that will eventually vanish forever. Their light is reaching us today, but the light they are emitting right now will never arrive. They are crossing a causal horizon, a one-way membrane in the fabric of the universe. If you were standing in one of those distant galaxies looking back at us, you would see a completely different observable universe. You would see galaxies that we can never see. We are effectively trapped in a bubble of information, surrounded by a vast, infinite reality that is systematically and permanently being deleted from our view. The universe isn't just big, it is fragmented. It is a collection of overlapping bubbles, and we are witnessing the only era in history where the full story is still legible. In the far future, the treadmill will have moved so fast that the night sky will be almost entirely black. Future civilizations will look up and see nothing but their own stars, concluding that they are alone in a static, empty void. We are the lucky ones. We are the generation that gets to see the true scale before the window closes. If you find this investigation into the hidden architecture of our reality fascinating, subscribe now. The investigation into how we discovered these impossible structures begins with a single grain of sand. To understand the true scale of the universe, you first have to acknowledge the limits of your own vision. Find a single grain of sand. If you were to hold that grain at arm's length against the blackest patch of the night sky, it would feel insignificant. To your eyes, it is blocking nothing but empty, silent darkness. But the data from the James Webb Space Telescope has revealed that this darkness is a lie. Within the tiny sliver of reality blocked by that single grain of sand, there are 800,000 galaxies. This is not a theoretical estimate. This is a measured count from the Cosmos Web Survey, the largest map of the deep universe ever created. Every one of those 800,000 points is a distinct collection of billions of stars. Each of those stars likely hosts its own planetary systems. If we were that wrong about one tiny patch of sky, we were likely wrong about the entire architecture of existence. In early 2024, the telescope was pointed at a region of the southern sky that appeared completely vacant to every instrument that came before it. After staring for hours into that void, capturing photons that had been travelling for almost the entire history of time, it found a fossil. It is designated JADES-GS-Z14-0. This galaxy is the most distant object humanity has ever directly measured. It existed just 290 million years after the Big Bang. To understand how early that is, we need to use a different kind of map, a calendar. If the entire 13.8 billion year history of the universe were compressed into a single calendar year, the Big Bang would happen at the first stroke of midnight on January 1st. Today, the moment you're living in right now, is the final second of December 31st. On this scale, our entire solar system doesn't even appear until late autumn. Dinosaurs don't arrive until late December. The entire history of human civilization occupies only the final seconds before the new year. The galaxy JADES-GS-Z14-0 formed on January 7th. We are looking at the universe's infancy. We expected to find a raw, unformed world of simple gas, but the data captured by Webb spectrograph revealed a complication that has sent a shockwave through the halls of every astrophysics department on Earth. This galaxy contains oxygen. This is not supposed to be possible. Oxygen is not a primordial element. The Big Bang only produced hydrogen and helium, with trace amounts of lithium. Every atom of oxygen in your lungs right now, and every atom detected in that ancient galaxy, was forged inside the core of a star, and that oxygen is only released into the universe when that star dies. Think about the timeline this requires. For oxygen to exist on January 7th, a specific and violent chain of events had to complete itself in the darkness before the dawn. First, the primordial gas had to collapse into the very first generation of stars, huge, massive monsters known as population 3 stars. These stars had to live their entire lives, burn through their fuel, and explode as supernovae to scatter oxygen into the surrounding void. Then that enriched gas had to cool down, collapse again, and form a second generation of stars. All of this had to happen, and then those stars had to assemble into a structured, luminous galaxy, all before the universe was 290 million years old. Before the James Webb Telescope, our best model said this timeline was barely enough for the first stars to even flicker on. Now, we have confirmed data showing fully assembled galaxies with complex chemistry already in place. One astronomer described finding this galaxy as equivalent to excavating a modern smartphone inside an ancient Roman ruin. The technology is too advanced for its era. The structure is too sophisticated. The timeline is not just fast, it is chemically impossible under our current understanding of physics. It suggests that the early universe was not the slow, gradual awakening we had modelled for decades. It was a sudden, violent, and impossibly efficient ignition. It means that stars were forming, dying, and enriching the cosmos at a rate that violates the speed limits of gas and gravity. We are finding that the universe was already busy building structure while it was supposed to be a dark, empty void. This too much light too early problem is a signal that our map of reality is fundamentally incomplete. But these impossible galaxies are only half of the crisis, because at the centre of these ancient systems, Webb has found something even more terrifying. Monsters that shouldn't have had the time to grow, yet are already devouring the light around them. As the James Webb Telescope stared deeper into the infrared fog, it began to find things that were not just old, but defiant. Scattered across the deep fields are hundreds of compact glowing embers that have earned a specific name in the scientific literature, little red dots. These are not just distant galaxies, they are a direct challenge to the rules of how the universe builds itself. This is not speculation. The data is real. It has been measured across multiple survey programs, and it describes a reality where the early universe is fundamentally more violent than we assumed. In our modern world, every large galaxy houses a central black hole. In our own Milky Way, that black hole is a resident, a tiny, stable heart that represents about 0.1% of the galaxy's total mass. On a human scale, if the galaxy were a 150-pound person, the black hole would weigh roughly 2 ounces. It is a rounding error, but in the little red dots, that ratio is 30%. If you were one of these galaxies, your central black hole would weigh as much as both of your legs. It is not a resident, it is the master of the system. This 300-fold increase in mass ratio is a signal that black holes did not grow slowly alongside their galaxies as we believed. Instead, they appeared first, grew aggressively, and dominated their surroundings before the stars could even find their footing. This leads us to a complication that physics says should be impossible. There is a theoretical speed limit for how fast a black hole can eat, called the Eddington limit. When matter falls toward a black hole, it heats up and emits radiation. If the black hole eats too fast, the light it produces becomes so intense that the pressure actually blows the food away. It is a self-regulating system, a cosmic choke valve that should prevent a black hole from growing too quickly. Yet, Webb has confirmed black holes like those in the little red dots are gorging on matter 40 times faster than the Eddington limit. To understand the scale of this violation, imagine a car with a top speed of 100 miles per hour. Now imagine that same car somehow travelling at 4,000 miles per hour. The machinery should disintegrate. The physics of radiation pressure says the black hole should have starved itself by blowing its gas away. Instead, these universe breakers ignored the speed limit and reached supermassive status in a fraction of the time we thought was physically possible. This too much too fast problem extends beyond the black holes and into the very gas that fuels them. When you try to build a galaxy, you're essentially trying to cool down a hot, chaotic cloud of gas so that gravity can pull it together into stars. But there is a thermodynamic crisis here. Physics dictates that you cannot compress gas faster than the speed of sound without creating shock waves that heat it back up. If the gas gets too hot, it cannot collapse. If it cannot collapse, it cannot form stars. Our models predicted a slow, inefficient process where only about 5% to 10% of available gas became stars over billions of years. The James Webb data has confirmed that these early galaxies were converting gas into stars with near 100% efficiency. They were turning entire clouds of gas into stellar nurseries at a rate that ignores the sound speed limit and the laws of heat transfer. This was not a slow awakening. It was a sudden ignition. This forces us to look at the deeper layer of the universe's architecture, the scaffolding beneath the light. For decades we believed in cold, dark matter, the idea that the universe is held together by invisible, slow-moving particles that clump together to form the valleys where galaxies live. But the elongated, perfectly organized shapes of the galaxies Webb is finding suggest something more profound about the nature of reality. We may be seeing evidence of fuzzy dark matter. In this model, dark matter is not a particle, but an ultralight quantum wave. Instead of discrete clumps, the scaffolding of the early universe may be a series of massive overlapping waves, a quantum sea that spans the observable cosmos. If this is true, the cosmic web was not built brick by brick. It was guided into existence by the wave-like nature of dark matter itself, allowing structure to ignite with an efficiency that our previous physics could not explain. The universe did not grow. It materialized along a pre-existing quantum map. We are finding that we do not live in the stable, predictable, clockwork universe we once modeled. We live in a place that broke its own rules at the dawn of time. But as we look at these impossible structures at the edge of the horizon, we have to ask why we're only seeing them now. Why did we miss so much of the map for so long? The answer lies in our own address, a quiet, empty suburb on the edge of a cosmic void. Right now, you're sitting in the middle of a cosmic desert. It does not feel like it. When you look up at the night sky, you see a dense canopy of stars and the luminous band of the Milky Way stretching over your head. Your world feels crowded, structured, and permanent. But this is the great deception of our specific location in the cosmos. While we assume we're living in a typical region of space, the data from the James Webb Space Telescope and large-scale structure surveys have confirmed a disturbing reality. We live inside a bubble of near-total emptiness. This is our real address, the KBC void. It is an underdense region of space approximately 2 billion light-years in diameter. To understand the scale of this emptiness, consider the Butter's void, a structure so vast that its discovery initially embarrassed astronomers. The Butter's void is 330 million light-years across. The KBC void, the one you are currently standing in, is 6 times larger. We are effectively living in a 2 billion light-year expanse where the average density of matter is substantially lower than the rest of the universe. If our solar system sat at the centre of a deep void like this without the surrounding local stars to light our sky, humanity might not have even confirmed the existence of other galaxies until the 1960s. We would have lived in an astronomical civilization with almost no evidence that anything existed beyond our own home. This is not speculation. This specific address has created a crisis that has occupied the greatest minds in cosmology for nearly a decade, the Hubble tension. The expansion of the universe is a confirmed fact, but when we try to measure how fast that expansion is happening, the universe gives us 2 different answers that refuse to agree. One method looks at the early universe, the fossil light from 380,000 years after the Big Bang, and calculates an expansion rate of roughly 67 kilometers per second. But when we measure the nearby universe using a distance ladder of stars and supernovae, we get a different number, 73 kilometers per second. For years, astronomers hoped this 6-point gap was a simple measurement error or a flaw in our older telescopes. But the James Webb Space Telescope has just confirmed that the discrepancy is real. By using its superior sensitivity to recalibrate the distances of stars, JWST ruled out the possibility of instrumental error. The tension stands at a 5 to 6 sigma level of statistical significance. In the world of physics, a 5 sigma result is the threshold for a confirmed discovery. This means it is almost a certainty that our current map of the universe is fundamentally broken. The reason for this tension may lie in our address. Because we live inside the underdense KBC void, the gravitational dynamics are different. Galaxies inside a void tend to be pulled outward toward the walls of the void, where the matter is denser. This imprints an additional velocity on everything in our neighbourhood. We are measuring the universe from inside a bubble, and that bubble is teaching us the wrong number for the fundamental constants of the cosmos. We are witnessing a multiplex of reality, where your specific location determines the physics you observe. But even as we drift within this void, we are not sitting still. We are part of a massive interconnected network of matter called the Laniakea supercluster. In Hawaiian, the name means immeasurable heaven. Laniakea is a 500 million light-year structure containing over 100,000 of our galactic neighbours. It functions like a cosmic watershed. Just as raindrops on a mountain are pulled by gravity into specific river basins, Every galaxy in Laniakea is being pulled along invisible channels defined by dark matter. We are currently flowing along one of these channels at a staggering velocity. The entire supercluster, everything you have ever known, is moving at 600 kilometers per second toward a region known as the Great Attractor. Behind the Great Attractor sits the Shapley concentration, a gravitational sink so massive it pulls on a significant fraction of the observable universe. We're falling toward an ultimate destination that is hidden from our view by the zone of avoidance, the thick dust of our own Milky Way that prevents us from seeing the very thing that is devouring our trajectory. To understand the scale of this motion, you have to look past the stillness of your room. Your coffee sits quietly in its cup, yet you're travelling at 1.3 million miles per hour. In the time it took you to hear that sentence, you moved roughly 60 meters through the dark. You're currently hurtling toward a massive concentration of matter on a journey that began billions of years ago and will never truly end. If you find this investigation into the hidden address we occupy fascinating, subscribe now. Right now, as you sit in the quiet of your room, you're being acted upon by a force that makes up 68% of the entire universe. This is not matter. It is not the dark matter scaffolding we have investigated, nor is it the light from the 800,000 galaxies hiding behind your thumb. It is dark energy, and it is the dominant mystery of our existence. For decades, we relied on a simple, comforting model called the cosmological constant. In this version of reality, dark energy is a fixed property of space, a constant, unchanging push that remains the same yesterday, today, and forever. But the data from the dark energy spectroscopic instrument has just introduced a profound uncertainty. This is not speculation. It is a measured deviation in the expansion history of the universe. The data suggests that dark energy may be changing. It may be a dynamic field that evolves through time, weakening or strengthening as the universe ages. This means the ultimate fate of everything, the star you see, the planet you stand on, and the atoms in your body, is currently caught in a three-way split between possible endings. We call these the three funerals of the cosmos. The first is the Big Freeze, or heat death. This is the outcome where dark energy remains relatively stable. Expansion continues forever, pushing every galaxy beyond our local neighborhood across the cosmic event horizon until they vanish from our sight. Over the next 100 trillion years, the stars will exhaust their fuel and go dark. The universe will become a vast, cold cloud of cooling stellar corpses, white dwarfs and black holes radiating away their energy over timescales of roughly 10 raised to the power of 100 years. Eventually the concept of temperature loses meaning. The universe does not end with a bang, but with a slow, eternal silence. The second funeral is more violent, the Big Rip. This occurs if dark energy follows a path known as phantom energy, where its repulsive force grows stronger the more space it creates. The timeline for this ending is terrifyingly specific. Approximately 2 billion years before the end, the gravitational bonds holding galaxy clusters together are severed. 60 million years before the end, the Milky Way itself is torn apart. 3 months before the end, our solar system is dismembered. 30 minutes before the final moment, the Earth is pulled into fragments. In the final fraction of a second, the force becomes so strong that it overcomes nuclear bonds, and atoms themselves are ripped apart. The universe accelerates through structure, then through chemistry, then through physics itself, until nothing bound exists anywhere. The third possibility is the Big Crunch, a theory revived by recent data suggesting the expansion rate might be decelerating. If the energy of space is metastable and eventually turns negative, gravity wins the war. In this scenario, the expansion of the universe slowly halts and reverses. The sky, which has been dark for billions of years, would begin to heat up again as the volume of the universe shrinks. The cosmic microwave background would concentrate back into visible wavelengths, turning the night sky into a glowing fireball. Everything that has ever existed would be compressed back into a single point, a final singularity where the story ends exactly where it began. We do not know which funeral is ours. The fate of the universe is genuinely undetermined between these three scenarios, each of which terminates reality absolutely. But there is a deeper, more immediate realization that the data from the James Webb Telescope has confirmed we are living in a golden age. We happen to exist in the only era of cosmic history when the full story of the universe is still legible. We can still see the afterglow of the Big Bang. We can still see galaxies from January 7th on the cosmic calendar. We can still measure the expansion and deduce the existence of dark energy. This window is closing. In approximately 100 billion years, the expansion of space will have moved so fast that every galaxy beyond our local group will have vanished behind the horizon. Imagine a future civilization arising in the deep future. They will look at the sky and see only the stars of their own merged galaxy. They will have no record of the Big Bang, no cosmic microwave background to measure, and no distant galaxies to reveal that space is expanding. They will apply full scientific rigor to the data available to them and conclude that they are alone in a static, empty, and eternal void. They will never know about the 93 billion light-year reality that we are privileged to map today. We are the lucky ones. We are the only ones who get to see the whole story before the window closes forever. This leads us to the final, existential truth revealed by the scale of the universe. The universe is not terrifying because it is big. We have known about its vastness for a century, and we have absorbed that fact into our textbooks. The universe is terrifying because it is temporary. The structures we see today are a brief, localized pause in a long story of chaos. We are a species that arrived late to the window, built a golden mirror to look out, and found that the view is already starting to fade. You're not insignificant because you are small. You are precious because you are a witness. You're part of the only generation that gets to know how large the darkness really is before it swallows the light.